Welcome to This Explainer. Today, we're diving deep to unlock exactly what examiners are looking for in the Cambridge AS and A-Level Information Technology exams. We're zeroing in on Topic 3.2. That's touch sensors for fluid levels, temperature sensors, and light sensors. You know, if you've ever walked out of an exam feeling like you absolutely nailed the material, but then your score just didn't reflect it, well, you're definitely in the right place. We aren't just going to rehash what these sensors do. Instead, we're going to decode exactly how Cambridge examiners want you to think about them, analyze them, and write about them. So, let's just get right to the elephant in the room. Why do top students who really know their stuff, still lose marks on these sensor questions? Are you maybe falling into this classic trap? Here's what happens. So many candidates spend hours and hours memorizing technical facts. They know exactly how a touch sensor measures fluid levels, they can rattle off the precise electrical resistance changes in a temperature sensor, or completely explain the inner workings of a light sensor. But when they actually sit down in the exam room, they totally freeze up when it comes to applying those facts to a specific problem. They end up writing down a textbook definition when the examiner's actually asking for a real-world application. It's all raw facts with absolutely zero analysis.
To avoid that trap, we've really got to understand the standard we're aiming for here. The Cambridge syllabus guidelines emphatically demand a mastery of fundamental principles, for sure. But more importantly, top-performing students have to show a connected, conceptual understanding that they can transfer to entirely unfamiliar contexts. Think about it like this. If you've studied how a light sensor works in a standard greenhouse, and the exam suddenly throws a curveball and asks about a light sensor in a deep-sea submersible, or maybe a smart city street lamp network, you shouldn't panic. You just need to take those core conceptual principles and dynamically apply them to this brand new problem.
So, how do we actually do this? Let's look at Section 1, Mastering the Methodology.
To stop losing those really easy marks, we need a radical mindset shift. We have to stop desperately scrambling just to quote-unquote find the correct answer. Instead, we're going to use what's called the method mark strategy. This is basically an exam approach where examiners actively reward your logical process. They are hunting for systematic processing. They want to see you interpret data, like actually extracting information from the text and tables they give you in the prompt, and then use evidence-based reasoning to draw your conclusions. You see, you don't just get points for reaching the final destination. You get points for proving exactly how you navigated the journey.
Okay, so the secret sauce here is knowing how to execute this strategy step by step. Let's walk through the 5-step procedural framework you need to attack literally any complex past paper question on touch, temperature, or light sensors. First up, Step 1. Deconstruct. Break the question down into its logical components. What information are they actually giving you? Next, Step 2. Extract. Pull out the relevant data from the scenario. Maybe it's a table showing fluid levels dropping over time. Then, Step 3, select. Choose the correct analytical framework or principle that applies to this specific data. Step 4 is execute. Solve the problem systematically, show clear working, and use clear notation. And finally, Step 5, present. Format your final answer using appropriate headings, clear annotations, and strictly correct terminology.
Once you have that methodology down, it's time for Section 2, critical analysis and evaluation.
If you want to hit those top grading bands in information technology, it's simply not enough to just describe a temperature sensor. Top scoring candidates demonstrate evaluative thinking, and a huge part of evaluation is comparison, specifically identifying similarities and differences. Let's say a question asks you to compare a light sensor approach versus a temperature sensor approach for a smart home system. A basic descriptive answer is going to fail. You absolutely must use comparative connectives. I'm talking about words like whereas, conversely, or similarly. And you have to back up every single comparison with specific evidence straight from the text, eventually drawing a really clear, justified conclusion about their relative importance.
Now I know what you're thinking. Dealing with all this high-level analysis means you need to be able to recall the technical data pretty effortlessly. Well, here's a powerful little memory hack for you. Encode these sensor concepts using a visual story method. Seriously, instead of just staring blankly at a bulleted list of how a touch sensor detects fluid levels, visualize a vibrant physical story. Close your eyes and imagine a massive industrial water tank. Picture the exact moment the fluid level rises, physically makes contact with the touch sensor, and triggers blaring alarm bells. Visualizing these sensors measuring temperature or light in a dramatic, real-world scenario firmly anchors the theoretical data in your brain. And that frees up all your mental bandwidth for the heavy analytical thinking we just talked about.
Now, before you take your exam, you need to hear Section 3, Top 3 Examiner Warnings. These warnings are pulled directly from the principal examiner reports. They reveal exactly where well-prepared students tragically drop the ball.
Listen to this quote because it is absolutely critical. The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. Guys, if you write a beautiful, technically flawless explanation of how a light sensor works, but you completely fail to explain how it works within the context of the automated greenhouse mentioned in the prompt, you are going to lose points. Generic answers are the absolute enemy of high grades. Context is literally everything here.
Let's rapidly fire off the top 3 documented mistakes so you can make a quick mental checklist before handing in your paper. Number 1, using the wrong approach for the context. Simply put, don't use a hammer when the scenario requires a scalpel. Number 2, ignoring format and presentation conventions. If you skip proper headings, mess up your terminology, or leave out clear annotations, you're literally just throwing away method marks. And number 3, which echoes what we literally just talked about, non-specific generic answers. Every single point you make must tie directly back to the specific fluid level, temperature, or light sensor scenario they put in front of you. So, what does this all mean for you? It really comes down to a choice. On your next IT exam, are you going to rely on generic memorization, cross your fingers, and just hope they ask a standard textbook question? Or are you going to execute the method mark strategy? Ditch the rote memorization, remember the steps, deconstruct, extract, select, execute, and present. Confidently apply this framework, link every single answer directly to the specific context, and watch your understanding and your grades completely transform. Thank you so much for joining me for this explainer. My final question to you is this: are you ready to stop studying harder and start analyzing smarter? Take this strategy and put it into practice today.